Hello there, guys, and welcome to class.
And where did I go wrong? I lost a friend somewhere along.
Teacher Krishna here. We are working on the science subject, and this is class number 3. Let's start. Here we have our title and end in mind for today. Lesson 3, Erosion and Deposition by Water. And the end in mind is to clarify general concepts and key terms from the topic Erosion and Deposition by Water. Alright, let's continue, and here you have the activities for today. First, read lesson number 3 and highlight the most relevant concepts. Remember that you have to access the online platform, and there you will have access to lesson number 3. Please make sure to read the complete lesson. And of course, identify the most relevant concepts. It is important to notice that lessons 1 and 2 will be evaluated as well, so students have to study them beforehand. So, I sent you some links last week to study a little bit the topics for this week, so I hope that you are ready. And also, you need to participate in the interactive quizzes game along with your team during the live session. So this is going to be our first evaluation. I hope that you are ready right now. Last week I told you that we were going to have our first evaluation. So yeah, it was very important for you to have it studied. Okay, so if you haven't, you can study as much as you can right now. So you can go ahead. And today, the winner team will get an extra point, so make sure to do your best during the activities today.
Yeah, boy.
Alright, let's start with our topic. And first of all, we have the question, how does flowing water change Earth's surface? So when we talk about flowing water, we can talk about rivers, we can talk about runoff caused by rain, and much more. Rivers and streams erode soil and rock and sediment. Sediment is tiny grains of broken down rock. So let's suppose that here we have a rain and it is flowing, and of course it is sort of affecting rocks around. So those little pieces of rock that go with the waves from a river are the sediments. Erosion is a process by which sediment and other materials are moved from one place to another. Please make sure to write down the most important words in your notebook. Erosion is an important word. So, when we move those little particles of rock from one place to another is what we call erosion. Erosion causes changes to Earth's surface. So definitely, every time we start piling up small rocks, the surface continues changing. Materials in rivers and streams are eventually dropped or deposited downstream. And here we have the deposition is the process by which eroded material is dropped. So again, when those little pieces of rock start piling up and they remain at a certain place is what we call deposition. Deposition occurs when gravity's downwards pull on sediments is greater than the push of flowing water or wind. For example, at a lake, let's suppose that a river actually goes and it ends up in a lake. So there are going to be some particles of rock that are just going to drop down and that are going to stay right at the bottom of the lake. So that's what we are going to know as deposition. A stream's gradient, discharge, and load are the three main factors that control what sediment a stream can carry. Gradient is a measure of the change in elevation over a certain distance. How high or how low is a surface. Rapid water flow over a steep gradient gives a stream a lot of energy to carry rock and soil. So we have that load refers to the materials carried by a stream. How much or how little material is carried by the flow of the water. The size of the particles in the stream's load is affected by the stream's speed. That's also very important. Fast-moving streams can carry large particles and have a high erosion rate. And slow-moving streams have smaller particles and have less erosive energy. Which pretty much makes sense, right? The faster we have a movement in a stream, the bigger the particles it can carry. Now, the slower it goes, the smaller the particles it will be able to carry out. This charge refers to the amount of water that stream carries in a given amount of time. So how much water, let's say, how big or how small are the currents or the sizes of the streams. A stream discharge increases after large storms and rapid snowfalls. As a stream's discharge increases, its erosive energy, speed, and load increase. That also makes sense. Imagine that it was heavily raining at some point. So, since it is going to have a bigger amount of water, then the discharge is going to be bigger as well. Here you have a small picture that represents weathering, erosion, and deposition. Weathering is what we learned last week. Remember, that is the breakdown of rock caused by several factors. Erosion means that we are going to move a lot of material from one place to another. For example, we are moving material from these mountains to this lake that we have right over here. When the materials stop, we are going to consider that as deposition because they are not going to move anymore. Now we have what landforms can streams create. A stream forms as water erodes soil and rock to make a channel. A channel is a path that the stream follows. Landforms such as canyons and valleys are created by the flow of water through streams and rivers. That's amazing. Imagine how a whole environment or a whole landform can be created just by the flow of water. When a stream floods, a layer of sediment is deposited over the flooded land. And we have a floodplain. It's a flat area formed from many layers of deposited sediment. So we're talking about deposited sediments again. Remember that all of those rocks are going to continue moving until they stop. And if all of these materials are staying at the same place, let's say, if they start piling up, we are going to have what we call a floodplain. Sediment often contains nutrients for plant growth. As a result, floodplains are often very fertile. Fertile means that a lot of plants can grow there because of the several nutrients that there are. And here you have an example of what a floodplain looks like. Just like you can notice, there are like these flat surfaces with a lot of water, a lot of animals, and grass, I would say. That's a floodplain. Let's continue. We have curves and bends in a stream channel are called meanders. Moving water erodes the outside banks and deposits sediments along the inside banks. During a flood, a meander can be cut off, forming a crescent-shaped lake called an oxbow lake. And here you have an example of what we were talking about just before. When everything is curved out, it is affecting the whole environment. This is represented in the picture right there. When a stream empties into another body of water, its current slows and it deposits its load. Just like the example I gave you when a river arrives to a lake, and the currents just slow down. A delta is a fan-shaped pattern of deposited sediment load. And an alluvial fan is a fan-shaped deposit that forms on dry land. And here you have an example of what an alluvial fan is. So this structure is pretty interesting. Just like you can notice, it sort of reminds us of the shape of a shell. And basically that's what we're mentioning right over here, an alluvial fan. Okay, now question. What landforms can you identify in the image below? Explain how each type of landform formed. Alright, so if you need to, you can go a little bit back on the concepts that we were analyzing about landforms, and you can try to identify them right here. We're going to discuss a little more about it in class. But first, try it out. Even though it's a little bit difficult, try it out. Alright, now let's continue. What landforms are made by groundwater erosion? Groundwater is the water located within the rocks below Earth's surface. Acidic groundwater can dissolve rock, forming underground caves. So, We can also think about groundwater as a river, let's say, but a river that is underground, and we can find about it. We can find them usually in rivers. Like if you have had the chance of being at a river and you see that water is just flowing out of the ground, that is groundwater because it is coming from under our feet, let's say. Water dripping from cracks in a cave's ceiling leaves behind icicle-shaped deposits called stalactites and stalagmites. If the roof of a cave collapses, it may leave a circular depression called a sinkhole. Alright, now we continue with what forces shape a shoreline. A shoreline is a place where land and a body of water meet. Ocean waves and currents or stream-like movement of water can erode and deposit material. Like imagine Champerico in this moment. Imagine the sun, imagine the water, imagine the beach. So basically the place where usually your family goes to, you know, where you find all of the sand, where you can walk around, where you see all of the waves coming to the shore. That's the shoreline, basically, where we go and we have fun with the family. And waves slow down as they approach the shoreline. The first parts of the shoreline that waves meet are the headlands, or pieces of land that project into the water. Waves striking headlands have high energy and erode material. Waves striking areas between headlands and have less energy and deposit material. Also, we have that longshore currents are currents that travel almost parallel to the shoreline, very near the shore. Longshore currents are caused by waves hitting the shore at an angle. As sand moves down a beach, the up current and of the beach is eroded away while the down current and of the beach is built up. Alright, so now what might this beach area look like in the future? What do you think? Notice that these rocks or these parts are being affected by all of the forces that come from the waves. So what do you think is going to happen to these two parts? Is it going to be the same or will they disappear? Think about it. We'll discuss it later on. Alright, now let's continue with what coastal landforms are made by erosion. The rate at which rock erodes depends on the hardness of the rock and the energy of the waves. Gentle waves cause little erosion. Strong waves from heavy storms can increase the rate of erosion. That's for sure. When there is a lot of storm activity, then waves are going to grow way taller. Or in case of an earthquake, remember that earthquakes produce tsunamis. And tsunamis are gigantic waves that come from the ocean. And again, that's going to be a pretty strong wave that can cause a lot of erosion in the shorelines. Besides destruction of human structures around. Very hard rock can slow the rate of erosion because it takes more wave energy to break the rock. Soft rock erodes more rapidly. Bays, sea caves, wave-cut platforms, and headlands can form as a result of differences in the hardness of rock. A sea cliff forms when waves erode and undercut rock to make steep slopes. As a sea cliff erodes above the waterline, a bench of rock called a wave-cut platform can remain below the waterline. The erosion of sea cliffs and headlands can create holes that become sea caves. Further erosion can produce a sea arc and sea stacks. Alright, and we have what landforms can you identify in this image below? How did each landform form? So try it out again, try this exercise before the class, and we'll discuss about it. And I know it might seem a little bit confusing, but don't worry, I will help you out in the class. Okay guys, so that's going to be it for today. It's been a pleasure being with you and see you in a couple of minutes. Goodbye.
Bye, have a great time.